All right, how are we doing? We are going to work on example 2 now. So again, first you want to think about which side do I want to work on. The general rule of thumb is you pick the more complicated side, whatever that may look like to you. And again, it's a general rule. I can't promise it works every time, but it's a good strategy to use. So I would argue the left side, once again, is our more complicated side. So let's focus in on that. So in the last question, in example 1, we wanted to identify, well, what can I change into sines and cosines? We don't have that issue here. Everyone is already a sine or a cosine, so what else could we possibly do? Well, there's a lot going on over here. Do we see that? One question that I might ask is there anything common to these two terms? And this is really similar to just algebra in general, right? So this is kind of asking, what is that GCF, or I'll write it off to the side here, greatest common factor. And the idea behind this is, say you had something algebraic, right? I'm going to use just x's and y's. X minus xy. Do we see the common x in those two terms? Okay, so if we factor out what's common and we leave what's not common, so if we divide this by x, that's just a 1, as I write an x, minus, if we factor out an x here, we're left with just a y, right? We actually want to do the same thing here, except here our GCF is not just a letter x, it's actually an entire sine theta. Do you see that that appears on both of those terms? So sine theta. So let's factor out a sine theta. I'm going to write it in parentheses, sine theta, just like we did with the x over here. This is just a sine on its own, so when I divide it by itself, I get a 1. Minus, when we divide this by a sine theta, and we can underline those, we divide that by a sine theta, we're left with cosine squared theta. Okay, so you may or you may not recognize this is one of the identities that we wrote down earlier, I believe in chapter 1, but earlier in this section. This is one of our Pythagorean identities. And it comes from sine squared theta plus cosine squared theta equal to 1. And if you can see, this is subtracting the cosine to the other side. So that means sine squared theta is 1 minus cosine squared theta. And so we can rewrite this. I'm going to copy and paste my sine theta that's there, but we can rewrite this as sine squared theta, keeping that other side the same. And then this just becomes multiplication. Sine times sine squared gives us sine cubed theta equal to sine cubed theta. And let's be fancy on this one. We'll write QED. All right, see you in just a moment for example 3.